We're about to break down exactly how you'd move on every planet in the solar system, from worlds where you can barely lift your feet to places where a casual hop launches you 3 stories high. We're starting with the absolute worst case scenario: Jupiter. Jupiter is the final boss of movement. The planet's surface gravity is 2.5 times stronger than Earth's, which means a 70 kilogram person would feel like they weigh 175 kilograms the moment they arrive. Every bone, joint, and muscle screaming under a load they were never designed to carry, jumping first. The average person can jump about 60 centimeters on Earth. On Jupiter, that same effort gets you 24 centimeters. That's about as tall as a sheet of printer paper is wide. You're basically not leaving the floor. Running is even worse. Every stride generates ground reaction forces between 3.75 and 6.25 times your body weight, well beyond what human joints can tolerate. Usain Bolt's top speed? On Jupiter, you're looking at a painful shuffle of maybe 5 to 10 kilometers per hour at absolute maximum effort. But here's the thing, none of that matters, because Jupiter has no solid surface. There is literally nowhere to stand. You descend through ammonia clouds into pressures exceeding 1 million times Earth's atmosphere and temperatures above 20,000 Kelvin. You'd be crushed and vaporized long before finding anything resembling ground. You thought gravity was the problem. There isn't even a floor. From here, every planet gets a little more forgiving, starting with another gas giant that still won't make things easy. Neptune. After Jupiter's nightmare gravity, Neptune sounds almost reasonable. At 1.14 times Earth's gravity, you'd only weigh about 14% more than you do right now. That's it. Sounds manageable, right? Here's the thing, you'd feel that 14% immediately. Every single step would carry a subtle but persistent heaviness, like wearing a backpack you can't take off. Your 60 centimeter vertical jump drops to roughly 52 centimeters. That's a 13% reduction. Not devastating, but absolutely noticeable if you're trying to do anything athletic. Running takes an even bigger hit. Usain Bolt's 44.72 kilometers per hour would drop to around 39 or 40 at absolute maximum effort, and you gas out way faster. Your body is now hauling a heavier version of itself with every stride, burning through energy reserves at a rate your muscles aren't built for. The extra metabolic load would have you doubled over and panting in a fraction of the time. But here's where it gets funny. None of that matters, not even a little. Neptune is an ice giant. There's no ground, there's no surface to stand on, run on, or collapse onto when your legs give out. And even if there were, the winds in Neptune's upper atmosphere exceed 2,000 kilometers per hour. That's faster than any hurricane ever recorded on Earth. Temperatures drop to around negative 224 degrees Celsius. You wouldn't just die, you'd be shredded and frozen simultaneously. Neptune is basically the solar system's slightly too heavy backpack, except the backpack is also a frozen wind tunnel with no floor. But if Neptune's modest gravity hides a death trap, wait until you hear about the planet that's somehow even more deceptive than this one: Saturn. Saturn is the cruelest joke in the entire solar system. Here's why. Its surface gravity is 1.06 times Earth's. That's it. A person weighing 70 kilograms on Earth would weigh about 74 kilograms on Saturn. That's the difference of drinking a large bottle of water before stepping on the scale. Your vertical jump drops from 60 centimeters to roughly 57 centimeters. A 5% reduction so small most people wouldn't even consciously notice it. Usain Bolt's 44.72 kilometers per hour becomes about 42 to 43 kilometers per hour. A gap so tiny a casual observer might miss it entirely. Saturn is on paper the most movement-friendly gas giant in the solar system. It's basically Earth with a slightly heavier backpack, and there's nowhere to stand. Saturn has zero solid surface. It's a swirling mass of hydrogen and helium all the way down. Those famous rings that look like cosmic highways? Loose chunks of ice and rock floating in orbit. You couldn't land on them any more than you could park a car on a cloud. Descend into the atmosphere, and you hit ammonia cloud layers at around negative 250 degrees Celsius. Pressures that increase catastrophically the deeper you go, and equatorial winds screaming at 1,800 kilometers per hour. That's over 5 times the speed of the strongest hurricane ever recorded on Earth. It's like winning a brand new treadmill and realizing you have no floor to put it on. Perfect gravity, perfect movement conditions, and absolutely nowhere to use any of it. But if Saturn's gravity is almost identical to Earth's, Wait until you hear about a planet where you'd actually weigh less than you do right now. Uranus. Here's where things finally flip in your favor. Every planet we've covered so far has either crushed you, slowed you down, or matched Earth so closely it barely mattered. Uranus is different. For the first time on this list, you'd actually move better than you do at home. Uranus sits at 0.88 times Earth's gravity. That means a 70 kilogram person drops to roughly 62 kilograms. Think of it like permanently being the lighter version of yourself from a few years ago. Not a dramatic change on paper, but your body notices immediately. Your vertical jump goes from 60 centimeters on Earth to about 68 centimeters on Uranus. That's a genuine 13% improvement with zero extra training. Same legs, same effort, better results. Running gets a bump too. Bolt's 44.72 kilometers per hour could realistically tick up toward 50 or 51 under the same effort because every stride generates lower ground reaction forces and your muscles burn less energy per step. You'd last longer and move faster. It's the best deal in the solar system so far. But you already know the catch. Uranus is technically an ice giant, not a gas giant. But that distinction doesn't help you. There's no solid surface. Beneath the hydrogen and helium atmosphere sits a mantle of water, methane, and ammonia compressed under extreme pressure, with a small rocky core buried deep below. Winds reach 900 kilometers per hour. And here's a fun detail. Uranus has an axial tilt of 97.77 degrees, meaning it essentially orbits on its side. One pole gets 42 years of continuous sunlight, while the other sits in total darkness. Even if you could somehow stand here, you'd want to pick your hemisphere very carefully. But at least Uranus only tries to inconvenience you. Venus actively tries to kill you. Venus should be the perfect planet. On paper, it's almost a copy of Earth. The gravity sits at 0.9 times what you're used to, which means your 60 centimeter jump on Earth becomes roughly 67 centimeters on Venus. Usain Bolt's top speed edges toward 50 kilometers per hour. You literally move better on Venus than you do on Earth. But here's the gut punch. None of that matters. Venus's surface is 467 degrees Celsius. That's hot enough to melt lead. The atmospheric pressure is 93 times that of Earth, which is the equivalent of being crushed nearly 1,000 meters underwater. The atmosphere itself is 96.5% carbon dioxide, with clouds made of sulfuric acid. You wouldn't take a single step. You'd be dissolved, crushed, and cooked simultaneously before your foot hit the ground. But here's where it gets genuinely wild. Between 50 and 65 kilometers above that nightmare surface, Venus has a sweet spot. The pressure and temperature up there are actually Earth-like, sitting between 20 and 37 degrees Celsius with similar atmospheric pressure. And because Venus's atmosphere is so dense with carbon dioxide, regular breathable air would actually float in it, like helium floats on Earth. Some scientists have seriously proposed building floating habitats up there, literal cities in the clouds. So Venus is the solar system's cruelest gravity joke, a planet where you could theoretically jump higher than on Earth, but you need to be living in a blimp to survive it. And speaking of planets where the gravity actually works in your favor and you can stand on solid ground, let's talk about the one you're sitting on right now. Earth, welcome home. After 5 planets where you'd either be crushed, dissolved, or fall through a sky made of liquid hydrogen, we're finally on solid ground. Literally, Earth's surface gravity sits at 9.8 meters per second squared. 1G, the number every other planet in this video is measured against. And your body knows this number intimately because it was built for it. Every muscle fiber, every bone density measurement, every tendon in your legs evolved over millions of years specifically to operate at this exact gravitational pull. You are a machine optimized for 1G and nothing else. So let's set the benchmarks. The average human vertical jump is about 60 centimeters, roughly 23.6 inches. And the fastest a human has ever run is Usain Bolt's 100-meter world record of 9.58 seconds, hitting a top speed of 44.72 kilometers per hour. That record was set in Berlin in 2009, and nobody has touched it since. Now here's the one piece of physics you need to remember going forward. Jump height equaled your initial velocity squared, divided by twice the gravitational acceleration. Gravity is in the denominator. That means every single planet below Earth on this list where gravity gets weaker, your jump height doesn't just improve, it skyrockets. The math gets dramatic fast, and speaking of dramatic, the very next planet on our list is the one humanity actually wants to colonize, and the movement upgrades there are no joke. Mars. Now we're talking. Every world up to this point has had a catch. No surface, no atmosphere, no way to actually stand on solid ground and move. Mars is different. Mars has dirt under your feet, rocky, cratered, rust-colored, regolith stretching to the horizon, an axial tilt of 25 degrees giving it actual Earth-like seasons. This is the first planet on our list where everything we've been talking about isn't just theoretical. You could actually do it here, and the movement upgrades are spectacular. Mars' gravity is 0.38 times Earth's. That means if you weigh 70 kilograms on Earth, you weigh just 26.6 kilograms on Mars. A 62% drop in effective body weight with zero change to your actual muscle mass. Your legs are still Earth strong. The ground just isn't fighting you as hard. That 60 centimeter jump on Earth, it becomes 1.58 meters on Mars. That's high enough to reach the rim of a standard basketball hoop from a standing start, something almost no human being can do on Earth. But here's where it gets really wild. Your flight time on a single jump stretches to around 3.5 to 4 seconds. On Earth, you're airborne for 0.7 seconds. On Mars, you have enough hang time to look around, reconsider your life choices, and mentally prepare for landing. Running transforms completely. Ground reaction forces drop by roughly 62%, meaning every stride carries you dramatically farther with dramatically less effort. Usain Bolt's world record sprint speed of 44.72 kilometers per hour could become a sustainable mid-effort running pace rather than an all-out maximum. You wouldn't need to be the fastest human alive. You just need to jog. Now you still need a suit. The atmosphere is 95% carbon dioxide at 0.6% of Earth's pressure, so breathing isn't happening. But structurally, a 1-ton object on Earth weighs only 380 kilograms here. Building habitats, moving equipment, constructing infrastructure, all of it becomes dramatically easier. Mars isn't just a cool hypothetical, it's the real deal. But if you think Mars gravity is fun to imagine, wait until you see what Mercury does with the exact same number. Mercury. Here's the thing about Mercury. Its gravity is 0.38 times Earth's. Sound familiar? It should. That's the exact same number as Mars. Identical. You jump 1.58 meters, run at the same enhanced speeds, and experience the same floaty stride mechanics we just talked about. Gravitational twins separated by millions of kilometers of empty space. But that's where the similarities end completely. Mercury is nothing like Mars. While Mars is humanity's best shot at a second home, Mercury is a radiation-blasted temperature furnace that wants you dead in every conceivable way. Surface temperatures swing from 430 degrees Celsius in direct sunlight to negative 170 degrees Celsius at night. That's a 600-degree range, the most extreme temperature variation of any planet in the entire solar system. And because one Mercurian day lasts 176 Earth days, you're not getting a quick cool down at sunset. You're spending the equivalent of 3 months in a furnace, then 3 months in a deep freeze. It gets worse. Mercury sits so close to the sun that solar radiation hits 6.5 times stronger than what we experience on Earth. That's lethal to an unshielded human within hours. And the planet has virtually zero atmosphere to provide any kind of buffer. No air pressure, no thermal insulation, no protection whatsoever. But here's the genuinely weird part. Mercury has confirmed water ice, sitting in permanently shadowed polar craters, cold enough to stay frozen despite being on the closest planet to the sun. Ice on Mercury. It's almost poetic. So movement-wise, Mercury and Mars are perfectly tied. Same gravity, same jump height, same running boost. But surviving long enough to actually enjoy any of that? Essentially impossible without engineering that doesn't exist yet. Mars is a future home. Mercury is a death sentence with good hops. But if you think Mercury's environment is harsh, wait until we talk about somewhere with no atmosphere at all and a surface humans have actually walked on. The Moon. Everything we've covered so far has been theoretical. Calculations, simulations, educated guesses about what it would feel like to move on alien worlds. But the Moon is different. Humans have actually been here. We have the footage, and it looked like nothing ever filmed before or since. The moon's gravity is only 0.16 times Earth's. That means your 60 centimeter jump on Earth becomes 3.6 meters on the moon. That's enough to clear a one-story rooftop from a standing position. Just push off the ground and sail over the building. No running start, no technology. Just your legs, but here's where it gets truly surreal. A single jump on the moon keeps you airborne for roughly 4 seconds. 4 full seconds of hang time. That stops feeling like jumping and starts feeling like slow motion flight. You push off and the ground just doesn't come back for what feels like an eternity. The Apollo astronauts figured this out almost immediately. Walking didn't work. Running didn't work either. The optimal way to move on the moon turned out to be bounding, a series of 2-footed hops that converted each stride into a brief flight. It covered ground efficiently and actually used less energy than normal walking on Earth. Every Apollo moonwalk is on record, and watching those astronauts bounce across the surface is exactly as surreal as it sounds. Humans have already done this, and it still looks impossible. The surface itself is covered in regolith, sharp, abrasive lunar dust created by billions of years of micrometeorite impacts with zero wind or water to smooth the edges. Those Apollo footprints from 1969, still there, essentially unchanged after more than half a century. Nothing on the moon erodes, nothing fades. The escape velocity here is only 2.38 kilometers per second compared to Earth's 11.2. You can't jump off the moon with human muscle alone, but that margin feels uncomfortably thin. And with NASA's Artemis program planning sustained human presence on the lunar surface, understanding how to move here isn't theoretical anymore. It's practical. But if you think the moon's 1/6 gravity is mind-bending, the next entry makes it look modest. Pluto. On Pluto, you weigh 4.4 kilograms. That's the weight of a newborn baby, except you're not a newborn baby. You're a full-grown adult with every muscle fiber, every tendon, every bone you've ever built on Earth. And you're standing on a world that barely knows you're there. That casual 60-centimeter jump you do on Earth, on Pluto, it sends you 9 meters into the air, nearly 3 stories, from a standing start. No run-up, no special technique. Just push your legs and you're gone. But here's where it gets genuinely surreal. That 9-meter jump keeps you in the air for 10 to 15 seconds. That's not a typo. You leave the ground and you have enough time to have a full conversation, film a short video, and still have a few seconds left to panic about the landing. You're not jumping anymore. You're flying with extra steps. Running becomes almost effortless. The metabolic cost of movement drops to roughly 5 to 10% of what it takes on Earth. Usain Bolt's world record sprint pace, the fastest any human has ever moved on foot, becomes a relaxed jogging speed on Pluto. You could hit 44 kilometers per hour without breaking a sweat. Your morning jog would look like an Olympic final to anyone watching from Earth. And the landscape you're bounding across, negative 232 degrees Celsius. Nitrogen, methane, and carbon monoxide exist as solid ice beneath your feet. The famous Sputnik Planitia Basin stretches over 1,300 kilometers wide, a massive frozen nitrogen plain that may sit above a hidden ocean of liquid water. The mountains are made of water ice so cold it's harder than granite. Pluto is smaller than Earth's moon, just 2,376 kilometers across, which means from the peak of a sufficiently high jump, you could actually see the curvature of the entire world beneath you. But here's the thing that genuinely terrified me researching this video. Pluto's escape velocity is only 1.21 kilometers per second. That's 4,363 kilometers per hour. Now, a human can't jump to escape velocity, but the margin between impressive jump and accidentally leaving the dwarf planet forever is uncomfortably narrow. A careless long jump with too much forward momentum in the wrong direction could send you drifting upward, slowly, gently, and never coming back. You wouldn't dramatically rocket into space. You just float away. Quietly. That's somehow worse. And that's the ultimate paradox of this entire list. The best place in the solar system for human movement is the farthest away, the coldest, the smallest, and the one that got demoted from planethood in 2006. Pluto, the underdog of the solar system, wins. If you enjoyed this video and want to see more, click the video on the screen now.